Hi guys, back at it, week 3. Let's see what we got in store for us today. Okay, well this is the first one that shows up where we have a trig function squared. Okay, so seems to me like I would want to isolate sine squared of x. So if we add 2 to both sides, okay, we're going to get 4 sine squared of x equals 2. And then if we divide both sides by 4, we'd get sine squared of x equals 2 divided by 4. They'd reduce down to 1/2. Now it seems to me we'd want to take the square root, and don't forget, every positive number has 2 square roots. Okay, so we would get the sine of x equals plus or minus the square root of 1/2. Okay. So let's see, that would give us plus or minus 1 over radical 2 would give us plus or minus radical 2 over 2. Okay, so let's see, this should work out okay. Okay, so I've got to worry about, okay, sine of x equal positive radical 2 over 2. And I have to worry about sine of x equal negative radical 2 over 2. Okay, so let's see what we got going on. Okay, let's sine, so let's go from 0 to 2 pi. Let's do that. And then let's also look, well, where would all our solutions be on the set of real numbers? Okay, so going to our unit circle. Let's start with radical 2 over 2, positive radical 2 over 2, and say, okay, sine. Well, remember, sine is our our y coordinate. Okay, so we look, well, when is our y coordinate positive radical 2 over 2? And that's going to happen here at pi over 4, and it's going to happen here at 3 pi over 4. Okay, so let's see. This guy right here would give us the solutions x equal pi over 4 and x equal 3 pi over 4. So that comes from these guys right here. Okay, but I still have to worry about these guys. Okay, so let's see, these guys, where are these guys going to be? Okay, so we go back to our unit circle and we say, okay, well, when will the sine of x be equal to negative radical 2 over 2? Well, sine is our y coordinate, so that happens at 5 pi over 4, and it also happens at 7 pi over 4. Okay, so let's see, we would get x equals 5 pi over 4, and x equals 7 pi over 4. Okay, all right, so we got four different solutions on 0 to 2 pi. And obviously, we get 2 from this equation and 2 from that equation. Okay, so on the set of real numbers, we'd have to take all of these guys, and we would have to add even multiples of pi, so 2n pi, where n's an integer. Okay, so we would get, let's see, x equals pi over 4 plus 2n pi. We would get x equals 3 pi over 4 plus 2n pi. We would also get 5 pi over 4 plus 2n pi, and we would get 7 pi over 4 plus 2n pi, where obviously n is an integer. Okay, that worked out okay. I don't have any problems with that guy. Okay. Let's try one with cosine. Okay. Notice it's very similar to this guy. So let's just approach it the same way. Okay, so let's see. How about we divide both sides by 8? So divide by 8, divide by 8. Okay, so cosine squared of x equals, that would reduce down to, what, 3/4? Okay, so I take the square root of both sides. So cosine of x would be equal to plus or minus the square root of 3/4, which would give us plus or minus radical 3 over 2. Okay, so I get one of these solutions will be cosine of x equals positive radical 3 over 2. And the other guy, cosine of x equals negative radical 3 over 2. Okay, so let's see what's going on here. We'll go 0 to 2 pi first. Okay, and then we'll do the set of all real numbers after that. Okay, so we go to our unit circle, and let's see. Cosine is our x-coordinate. So we're looking for, we'll start here. Let's see, cosine is positive radical 3 over 2. Well, that would happen at pi over 6 right here. Okay, right here. Our x-coordinate is radical 3 over 2. It also happened down here at 11 pi over 6, where x-coordinate is radical 3 over 2. Okay, so we have x equals pi over 6 and x equals 11 pi over 6. And those solutions are coming from this guy. Okay, so now I have to worry about the solutions that come from this guy. Okay, so let's see. When is our x-coordinate negative radical 3 over 2? Well, notice that happens right here at 7 pi over 6. And it happens right here, oh, wait a minute. No, I'm sorry, it happens up here, 5 pi over 6 and 7 pi over 6. Okay, we get our x-coordinate is negative radical 3 over 2. Okay, so 5 pi over 6 and 7 pi over 6. So x equals 5 pi over 6, and x equals 7 pi over 6. Okay. Once again, 4 solutions. So let's see, again, we're going all real numbers. So cosine has a period of 2 pi. Okay, so we would get x equals pi over 6 plus 2n pi. We would get x equals 11 pi over 6 plus 2n pi. We would get x equals 5 pi over 6 plus 2n pi. And we would get x equals 7 pi over 6 plus 2n pi, where obviously, once again, n is an integer. Okay, so those guys are real similar. All right, let's try one more here. Okay, we got something going on with secant. Okay, let's see what happens here. Well, I know I want to gather these guys up. Okay, so I know this guy has to come over here. Okay, and so if I'm going to collect the secants on the left, I probably ought to collect the constants on the right. Okay, let's see what happens. 5 secant squared minus 2 secant squared gives me 3 secant squared. 3 secant squared of x equals, and then let's see, negative 4 plus 7 would give me 3. Okay, so divide both sides by 3, and I get secant squared of x equals 1. Take the square root of both sides, so I get secant of x equals plus or minus the square root of 1, which obviously gives me plus or minus 1. Okay, so I have to worry about, when will secant of x be positive 1, and when will secant of x be negative 1. Okay, so if we're going to work on the unit circle, we want things in terms of sine and cosine. So let's see, secant is the reciprocal of cosine. Okay, so if I take the reciprocal of both sides, I get cosine of x equals the reciprocal of 1 is just 1. Okay, so I got to work with this guy. Over here I do the same thing, take the reciprocal of both sides, so I get the cosine of x equals the reciprocal of negative 1 is still negative 1. Okay, so this is the guy I have to work with. Okay, so let's see what happens here. From 0 to 2 pi, Okay, and then we got to go a set of all real numbers. Okay, so let's see. When will the cosine of x be equal to 1? Okay, so remember cosine is our x-coordinate. So when is our x-coordinate equal to 1? Well, that only happens right here at 0 or 2 pi. Okay, so I'm just going to call it 0. That's the only time it happens. Okay, so this guy gives me x equals 0 radians. Okay, and I got to see, well, what's this guy give me right here? Okay, so when will cosine be equal to -1? So when is my x-coordinate equal to -1? And that only happens right here at pi. Okay. All right, so this will give me x equals pi. All right, so this guy only get 2 possible solutions overall. Okay, so let's take a look. What can we do? So we can say, okay, on the set of real numbers, that would be 0 plus 2n pi. Okay, and this would be pi plus 2n pi. Okay, so let's see. I'm taking a look at these. Now, technically, we could leave it the way it is, but I'm thinking, okay, we're obviously, n is an integer. But I'm thinking, is there an easier way to do this? Okay, or, okay, well, 0 plus 2n pi is just 2n pi. And we know 2n pi, when n's an integer, those are all the even multiples of pi. Well, if 2n pi is even and we add pi to it, that has to be odd. So these are all the even multiples of pi. These are all the odd multiples of pi. So put them together and we have every single multiple of pi, both odd and even. So the best way to do this would just be x equals n pi, okay, where n is an integer. Okay, I'm not saying this is wrong. Don't get me wrong. I'm not saying, you can't do that. That is correct, but this would be best form of the answer. This guy right here would be best form. Okay. All right, so that's it for today. And I think we have a couple more problems to do tomorrow. So you guys stay safe out there, and I miss you a whole bunch.